Now let's look at that annotation that I was talking about. What is this annotation and why it has to do, or what it has to do with the Java? Annotations are the attributes or qualifiers for the program elements. They are the data that describes your program. They are not your business logic. So you are describing your code to the compiler or to the container. You are telling the container that this is a session D, this is a stateful D, this is an entity. You know very well session D will contain some business logic. Some kind of coding will be there, that is the Java part. But I'm not talking about the Java part. When you give a class or when you give an object to the container knows that this is a Java object or this is a Java class I'm supposed to execute it. That's well and good. But how do you talk to the container and say that this is a Java class and you will have to treat it like a session object? It looks like an ordinary class, but it is not an ordinary class. It's a session D. It's an entity D. It's a remote interface. How do you talk to the other side? Now, when you say something is a session bean or something is a stateful bean, stateless bean, you will have to write some code inside it. That code is some business logic or some programming logic that you are using Java syntaxes like if, then, else, and while loop, for loop, and so on. You write the program. The program will describe what is the process or the logic to the execution engine. But how do you talk or how do you give some additional information apart from this business logic? The way in which you do it is you use the annotation. Annotations are like metadata. You have studied about the databases wherein you have heard about this metadata, data about the data. So here it is some data about your program. And if at all you want to do it, you use the annotations. Now let's look at what's the use of this particular annotations. Now annotations can be used to communicate with the compiler, with the container, or with the runtime environment. So you can use annotation to talk to the other components of Java. The olden days when the annotations were not there, people used to follow the same idea of annotation, but that was not provided directly by the Java community as such. They used to use a technique called as xdoclet, which is a way in which you write the metadata in a remark statement. So one of the reasons why people use the annotation is to create the boilerplate code. Now what is this boilerplate code? Now if you notice here, if you go back to the olden days, you are supposed to create this, you are supposed to create the bean, you are supposed to create the remote interface, you are supposed to create the mobile interface. And I have told you that when you create a bean, automatically the container will create the bodyguard for it. Automatically the container will create a stub for it. Similarly, when you create the home interface, automatically the container will create the stub for that home interface. This is done automatically. This is an ordinary class. You give a class to the container. How does the container know that it is supposed to create additional objects based on this structure? You have to talk to the container. The way in which they used to do it is they used to use the xdoclet technique. Now, creating something extra based on your code is called as boilerplate code. What is this boilerplate code? Is additional code that is getting generated out of it. So when you give this interface, it creates a class out of it. When you create the other remote interface, it creates a class out of it. This is the boilerplate code. How to generate that boilerplate code? You have to communicate with the container. The way in which it was done is people used to write a remark statement. You know very well what you write inside a remark statement, Java will not bother about it. So remark statements are meant for humans. it is not meant for the compiler. So the instruction to create this boilerplate code was written inside a remark statement. So whatever you write inside this remark statement, Java will not bother and Java will not object anything inside it. But this X.let was a separate parser. What this parser is to do is, when the code is going to this parser, it will read that specially written remark statement, and whatever that is written, whatever instruction that is written inside that remark statement, it used to interpret it, and then it used to generate the boilerplate code. So in olden days, what people used to do is they used to create the classes, write a remark statement in the X.let format, give it to the X.let parser, it will read that remark statement and then create the boilerplate code for you. So this was the idea that people were using, and this X.let was not a part of Java. It was a help that was provided in olden days. Now one of the problems with the X.let was written in the form of a remark statement, and there was no type checking. If you were not very careful in writing the remark statement in the proper way, X.let used to misinterpret it and everything used to crash. So your program may get compiled, but the boilerplate code that it was generating was not appropriate because the code was not proper. So what people thought about the Java community thought about it is, why not include this feature into the Java itself? So in the year 2004, they introduced the JSR 175, which changed everything. And this is where they introduced the annotations. Now, annotation is a way in which you write the Java syntax. It's part of the Java now, but that particular piece of code will help not only the compiler, but it will also help the container to interpret and generate the boilerplate code for you. So now everything was part of the Java, and if you have not written it properly, or if there is a syntax error, Java is to stop the code and it will complain and say that this is not proper. So this was a major shift that they came about, and the reason why they introduced these annotations for it, using the annotation, it is possible to supply some extra information to the compiler. For example, you can tell the compiler not to show the warning messages. So usually compiler will show a warning message saying that this is not proper, that is not proper. You can just tell the compiler, don't try to show the warning message, or interpret it in a separate way. Again, you can also use the annotation to talk to the container. You can tell the container that this particular code has to be executed in a separate way. Also, you can use some of the annotations can be detected at runtime. When the code is running, a technique called as a reflection can be used to figure out what the code is supposed to do. So annotations were very different altogether. Which are the things that can be annotated? You can put the annotation in packages, you can put it in classes, you can put it in databases, you can put it in enumeration, a method, or as a local variable, or give a formal parameter. This is only done at the compile time. It is not possible for you to put the annotation at runtime. When I say you can put the annotations are part of the Java. That means to say that you can create your personalized annotation. It's not that there are some annotations and you are supposed to use it. If you want, you can create your own annotations because it's now part of the Java syntaxes. We will not be venturing in creating an annotation because annotations were, if at all, if were to be included, it would have been included by now in your last semester, because annotations are not part of the Java EE. Annotations are part of the core Java. From 2004 onwards, that is 10 years ago, that has been incorporated into the core Java. Now let's look at what is the difference between putting an annotation and writing a remark statement. Now if you notice over here, there are some remark statements. For example, there is a remark statement that says that object this field is never null. This is an instruction to the programmer. Compiler will never bother about that. Even if the object is null there, even if that field is null, compiler will not complain and say anything to you because this piece is a instruction to the programmer, not to the compiler. The same thing is true. You are giving an object to C here, P here, and you are giving a remark statement that if at all you are supplying, P should not be null. This is an instruction to the developer. It's not an instruction to the compiler. Now, what happens when you give this particular program to the parser, the Java parser? I hope you know how the compilation takes place. Initially, your code is parsed. There will be 3 stages for compilation. Here, that is the last semester's work. Now, when it is given to the parser will create a syntax, abstract syntax tree. Now, this is a verification of the syntax. This is how the parser will tell you that there is a syntax error, there is an opening bracket that is missing, or a closed bracket is missing, or a semicolon is missing. That is because it generates a balanced tree. If the tree is not balanced, it immediately will complain to you. But when it creates this tree, you will notice that all your remark statements are stripped out directly at this parser itself. So whatever comments that you write, parser will strip it out and put it into the bin. So it's all gone. Your effort will not go to the compiler side. The compiler will never even see that remark statement. What happens? Usually if you write that code, parser will check, remove the comments, and then if everything is proper after this, you get this syntax tree. This syntax tree is given to a type checker to see that the syntax is proper. If the syntax is proper, if there is no error, it will create a class file for you, and that class file is your Java class. This is how you usually work. But what happens when you use the annotations? When you use the annotations starts with the special symbol @ followed by an annotation. There is a class file associated with this annotation that says what is the actual meaning of it. It is not just putting null, it's all over. When you put null, there is a class that will describe what is the meaning of that null. It's a syntax by itself. So when you specify this particular thing, it is easier for a developer to read and understand that this piece is not null. The developer is able to understand that. But what happens when it is given to the parser? Parser will not strip out this annotation. Rather, it will keep that annotation as a separate attribute with the parser tree or an abstract syntax tree. This tree is now given to a type checker which will check for the type syntaxes, that is your syntax verification. After that, it will pass through one more checker, and that is the annotation checker. It will check for the validity of the annotation. If an inappropriate annotation is provided, your code will not get compiled. The compiler, it will not go for the conversion into the your byte code. Instead, the compilation will stop there and there itself. If there is no error, and if the annotation checker says that the annotations are proper, I am able to understand what is this annotation all about, it will go to the class writer and it will create the Java class for you. So this is the idea of annotation. Annotation is a way in which you describe something to the compiler or to the runtime environment or to the container. You don't put the remark statement, you put the annotation. Annotation are easy. Annotation work like a remark statement because the word can be read by a developer and it is easier for a developer to understand that this is a session page, this is a remote interface and so on. So instead of putting a remark statement, you can put the annotation. The advantage with the annotation is remark statement is picked up directly. It won't go beyond the first parser. whereas the annotation can be there even at runtime. So you can pass the annotation even to the runtime, and at runtime somebody can prove that annotation and get the meaning out of it. So that's a good thing about it.